Very good morning to all. It's our great pleasure to have you all for the Knowledge 4.0 webinar series, which is one of the unique initiative of Chennai Institute of Technology under the guidance of our Honorable Chairman, Mr. P. Sriram, a successful first-generation entrepreneur, a well-known industrialist, a managing director of MK Group of Companies. So under Knowledge 4.0, we have been conducting a series of webinars such as Technical Webinar Series, Research Webinar Series, Career Guidance Webinar Series, and Innovation Webinar Series. Chennai Institute of Technology was established in 2010 by our chairman, Mr. P. Sriram. Now, our institute is being within top 10 institutes among private engineering colleges in Tamil Nadu. Today, we have the Technical Webinar Series named as Mechanical Engineering and Beyond, which is going to be handled by Dr. Ganesh Kumar. I warmly welcome Dr. Ganesh Kumar for accepting to be today's program guest. Thank you, sir.
Thank you.
So to say a few words about Dr. Ganesh Kumar, he completed his mechanical engineering from Anna University, and then MS from Kettering University, and a PhD from Purdue University, USA. After that, he started his career with Eaton as a senior engineer, and then engineering project manager in Siemens PLM software, and currently he is project manager of CNH Industrial, that is Case New Holland Industrial in USA. So it's our great pleasure to have you for this session, sir, for the title Mechanical Engineering and Beyond. And over to you.
Hey, thank you, Bala. Thank you for the nice introduction, and thanks for also inviting me to give this talk. I hope everybody is staying safe at home, social distancing and all that. So hopefully we will get through this situation that we are all in. And probably it's a good morning to all of you, and for me it's almost 11:40 in the night. This talk is mainly for engineering, but the talk, little of the technicals I've included is for mechanical engineering students, just to get them inspired. It's not a really in-depth technical talk, just an overview of what students can expect from mechanical engineering when they get out in the to the industry. So without much further discussion, I'll start the presentation. And okay, this is the agenda for today. I'm going to just give a brief introduction of why this talk, why this webinar, and I will be talking about what are the different areas in mechanical engineering. This is not Master of Engineering, mechanical engineering. What are the skills in each area, and how the students in second, third, or fourth year of mechanical engineering should prepare themselves or build their skill set when they are about to graduate in the fourth year. So, and I have some recommendations, and we will end with the question and answer sessions. This talk is mainly to give an industry perspective, like what the industry is expecting from the students. So when a student says, I graduated from mechanical engineering, well, industry, if you're getting into the industry, the hiring person will say, okay, good. What else? He's going to say, I am this company, I'm a software company, I'm a car manufacturer, I'm an aircraft manufacturer, I'm an agricultural company. So for me, what are you going to do? So that will be the next question. So what does the industry expect from, let's say, a mechanical engineering student? And this can be broadened to other engineering branches as well. So if you take mechanical engineering, it's not a single branch or a single area. I mean, it's ever expanding, and there are a lot of areas that are grouped into mechanical engineering. So, which is the case in also other departments of engineering. So, since I went to Purdue, I just took a page from the Purdue engineering website showing what are their areas of interest in mechanical engineering. So Purdue lists all these things. Most mechanical engineering students will know that, oh yeah, I know that course, I've taken that course, and so on and so forth. So if you just broadly see that, they've categorized into like acoustics, bioengineering, combustion, computational engineering, design, fluid mechanics, heat transfer, HVAC, manufacturing, and so on and so forth. And the last one, systems, measurements, and controls, which is my area of interest, and that's my area of that's why I'm working on. So some of these, for example, bioengineering was not even there when I was studying 20 years ago. So things change, and a lot of universities are keeping their areas of interest up to date. So that's my alma mater. So let's see how University of California, Davis, UC Davis lists lists the areas of interest in their mechanical engineering. So right away, hot topic: biomedical and engineering, fluid mechanics, combustion and the environment. That's a good old mechanical engineering. This I have not seen in a whole lot. There's a separate area of interest called ground vehicle systems, and heat transfer and thermodynamics, which all we know, manufacturing, mechanical design, system dynamics and control, transportation systems. So I was curious, what's that? They have ground vehicle systems as a separate area of interest, and I just put there what they mean by that. So that area covers all the innovations which relates to vehicle dynamics, propulsion, new engine technology, new fuel, or alternative to fuel, like electric powered or fuel cell. So all that is grouped under that area of interest. So this is just to give an idea to students. When you study mechanical engineering, you cover a lot of different areas of interest through the 4 years of engineering when you study through different classes that you take. But you cannot be a master in all of them. You can try, but it's very hard to become a master in all of them. You have to choose one area of interest, which is for some people it just falls into their hands, or for some people they really are passionate about something. For example, if you're passionate about environment, you will of course study some alternate fuel or fuel cells or in that. And if you're interested in manufacturing, you will choose a similar area in manufacturing. So my area, how I chose is my area is still system dynamics and control. How I selected that course is very, very interesting story. When I was in my 4th year or 7th semester of engineering, you could choose a lot of different electives. So the one elective I chose is not from mechanical engineering department. I went to electrical engineering department, and there a professor there was offering, her name is Uma Maheshwari, she's still professor there. She was offering modern control systems elective, and she said it's all open to all branches of engineering. And one of my friend was very curious, and he asked me, would you join me in taking that class? Only if you are taking, I'm taking. He just wanted a buddy to go. If things cannot go as expected, he wants somebody to to help each other. So I said, yeah, sure, I'll take it. So 3 people out of 128 mechanical engineers, 3 guys took that system dynamics or modern control systems course, and that gave me a completely different view of mechanical engineering. Mechanical engineering cannot be bound by what you just study in the 4 years of college. It's much more than that, and that's why I even defined the topic, the title as mechanical engineering and beyond. So, and from there on, I started, the modern controls, that modern control systems gave me a good background for system dynamics and control for me. And then from there on, I did my master's and PhD, and then further works I did. I was always involved in some form of control, and I was slowly building up the system dynamics and control. So my area of PhD is hydraulics, but I used system dynamics and control when I was still researching hydraulic systems. This is just to give, again, don't confine yourself to I'm a mechanical engineer, what can I do? No, it's not that simple. So now, what is your area of interest and what is your skill set? This is a very very common question that the industry might ask. So you are a mechanical engineer, sure, but what is your area of interest and what is your skill set, and how do you define that? So let's see what skills I do have now. But I will list all the skills I have accumulated up till now. But for a graduating student, he still can have a quite good set of engineering skills. Okay. First of all, what is a skill? Okay. The skill is defined in the dictionary as the ability to do something really well, an expert. Okay. When they call you an expert in something, that means you have learned a little bit more than others in that area. So coming to what I do. So I work on this machine, combine harvester, and this is a miracle machine. When I joined CNH in 2016, I was working on the ground drive part of it. Ground drive is basically a big hydrostatic transmission which moves the combine. Okay, and it took me about 2 years to go to a real field in a harvesting condition. And in those 2 years, I have climbed on the machine multiple times in our lab. Okay, but when it was actually harvesting, I've never seen one. So after 2 years in CNH, when I went to the real field, I was blown away how the machine, everything works together. So let me share a small video of how the internals of the machine work. So this is a multiple system that's put together as one system and put on wheels. It's actually a mini factory on wheels. We don't see these harvesters in India because we do have harvesters in India, but not of this size. We have smaller harvesters. These are for really 500 acre to 1,000 acre and 10,000 acre farms. They usually have these big harvesters. These the front of the machine is called a header. That can be up to 40 feet long. So basically what a combine does is that for different crops, there will be different headers to cut the crop. So what it basically does is cuts the crop, gathers everything, all the cut crops to the center of the combine and feeds it inside. Okay. For example, let's say you're harvesting wheat. So it will cut all the wheat, the top of the wheat, put it on this. There's a conveyor belt here going from the side to the center. And then when it's all reaches to the center, they're all fed into this conveyor that feeds the wheat grains with everything, the whole wheat chaff. And then it threshes the grain, just like how would you do, I don't know if you see in the villages, how do they thresh the grains, and then you will thresh the whole plant, so the grains fall off. And then now the grains will have still the husk, and then they will take it to the mill to remove the husk, and you get the whole wheat then. This machine does everything as it is moving through the field. So it cuts it, sends it through. There is a big drum in the center that rotates, that will actually thresh the grain and also remove the husk from the grain. And the grain will fall on different sieves. So the sieves will separate a lot of husk and chaff and let only the pure grain fall into the final sieve. There are actually 3 sieves, and there's a fan to clean out all the husk. Only the clean grain falls into a grain bin, and from there it is actually sent to the top of the machine. So let's see a video to quickly see what I'm. Oh. So like I said, in this video, the header is not shown. They're assuming that the header is doing its job and feeding it to the front of the combine, but it's pushing it up. So as it comes here, there's a big drum, and this drum has coverings called crates, and that's where the grain is threshed, between the drum and the grates. And the grates have holes in them, and that's how they like it'll be like this with a lot of holes, and the grain will fall through. And the bigger crop, which is we call mat or chaff, some of the bigger material will just go through. It will not fall in. Right there, the grain falls into a sieve, and there are multiple sieves. There are 3 sieves. There is a pre-sieve, there is a lower sieve, and an upper sieve. So they fall gradually so that, oops, sorry. So they will gradually fall into the 3 sieves, and then the clean grain will fall into the grain bin. And there is a fan. There's a fan to blow out all the chaff. So that is the chaff that comes out, which is, we don't want it. So they will chop it up and spread it out. Some farmers want finely chopped, and some farmers want it not so finely chopped. And there are settings for that. You could chop however you want, and they will spread it into the field to keep the organic content in the field rather than taking it out. I'm sorry, I don't know why the video stops after playing for some time. So here, basically from the bottom of the combine, there is called grain elevator, which is just an auger, like a screw type auger, that's bringing all the grain into the grain tank, which is on top of the machine. That's where they store the clean grains. So I'll share, in the chat window, maybe I'll share another video. There are a lot of videos how combines operate. You can have actually a lot of fun watching that, the videos. There's big groups in YouTube to like compare whose combine is better, and and so on. But it's fun to watch. Like I said, the first time I saw a grain harvested, it was soybeans harvested. So all I saw was in front of the combine there are dried crops, I mean, it looked like it had soybean pods in it, and it's all dried up. And at the bottom, I just saw fine dust flying through. And I said, what happened? and all the clean soybeans is stored in the top of the grain. It was just amazing. Like, I mean, if you can see some videos, there are actually a lot of good videos on YouTube. I mean, Google it when you guys have some time. So that's all fun, right? So what does it involve to run this machine? Mechanical engineering, you need to design the machine, design each and every part. You have to manufacture it, and there is a lot of electrical wiring, hydraulic wiring in the combine. You have to route the harness. That's also part of design. I mean, you do that in Pro E mostly. And materials, you have to choose the correct materials, because you're always coming in contact with water, so you cannot on moisture, so you have to have corrosion resistant material. It has to hold the strength of different parts. So hydraulics, I mean, most of the actuators in the combine are actually rotary hydraulics, and there are some electrical too. Packaging, you need to compactly package everything, and because after the harvest is done, it still needs to travel on the road, so you cannot have a huge machine, so it still has to follow the road track. Everything has to be in the compact, however wide the road is and bridges are, you have to fall into that package everything so that it can go on the road. Engine, that's a separate topic. I mean, there are different classes of engine for different types of combines. The bigger the combine, the bigger the engine, because it takes in more. I mean, all the actuators are sized much bigger to handle much more load in a shorter time. Electrical, again, there is a lot of electrical parts, lot of electrical interface, switches, lights, actuators, solenoids, battery, all of them needs design. They need to be manufactured, and again, materials, wiring, packaging. So even electrical engineering just cannot say that, oh, I don't know packaging. So he cannot just say that. He has to work with whoever is in charge of packaging. He needs to be able to work with him to understand what are the needs. Okay. Communication, there is CAN lines, there's Wi-Fi, there's GPS, there's computer design, which always, I mean, it's not exactly computer science, it's also electronics, right? So CPU design, there's a lot of logic built into these machines. These are not just you turn on a switch and then it just runs like an electric bulb. No, there's a lot of logic built into how each of the actuators are controlled, and that logic needs to run in a CPU, and the CPU needs to be designed efficiently, and how many IOs that CPU can take in, so those are all designs for ECE students. Computer science, you need to program that controller, you need to manage the software, you need to release the software, test it, validate it, release it to the customer in the proper way. And that's kind of currently my task is software management, though I do technical execution too. So these are all the things that, I mean, of course I missed a lot of things. Management, okay. If somebody has managed all these departments, okay, whether they're talking to each other properly, there's timelines, there's cost, which I did not even include here. Finance comes in. Costing is a big deal because you're always pressed to reduce cost. Like I said, I was involved initially in the ground drive part. The ground drive is a big hydrostatic system that moves the combine, and you can just say that a ground drive simple hydrostat, but then there are park brakes, there are service brakes, there is a rear wheel assist, just like a 4-wheel drive in your car. There is diff lock, and there are user controls. The user, so all these hydraulic, hydro-mechanical, and electronic components need to interface with the user, and there is user interface. So the skills I use for my job when I started the job was, I did not have all the skills that I'm using right now, because I'm 4 years into the job. But initially I had some set of skills, and that's why the company hired me. So, dynamics of system, core mechanical engineering, right? Machine design, especially transmission. You need to know how the transmission works. You need to understand what is the gear, what is the gear ratio, how can you convert from one to the other, what is a diff lock, what is a differential. So you need to know all these basic things. So that's basic mechanical engineering that I did not find somewhere else. I studied when I was in college, hydraulic system. Well, that was my doctoral research. So I did have a lot more hydraulic system knowledge when I joined this job. But a lot of our my co-workers here, they come up with the basic hydraulic knowledge that they gained in college, and that's pretty much sufficient. You just have to learn it well when you're learning it. Electrical basics. So I need to know simple wiring circuit, simple diagram. When somebody says that, hey, here's your sensor for sensing your ground speed, and this sensor is operating in this much voltage. This is the sensor range, and this is the sensor supply voltage. I cannot say that, hey, I'm a mechanical engineer, I don't understand. No, you cannot say that. You have to at least make an effort to understand simple electrical circuits. In industry, people understand. If you are from a certain background, they will always understand that, oh, okay, he's from that background and he must not have this background, so let me help him. They will always do that. So don't think that how will I go to this company and this industry where I don't know a lot of things. I know a little bit, but I don't know a lot of things what they do. Do not have that thinking when you look at a industrial job or industrial position. So because nobody, like I said in the beginning of my talk, you cannot be a master of all the areas of engineering, right? Even, let alone mechanical engineering. There's in engineering is it's just like the saying, what you've learned is just the size of your fist, and what you've not learned is the whole world. So where did I stop? Electrical basics. Instrumentation, we do learn that, sensors and actuators. Controls, that I learned from that elective, MATLAB, Simulink, C. Programming, this I did not learn, but I learned later in my working career. And CPU working, that I did not learn in engineering, but as you are pushed into a job, CPU is there in electronics. In mechanical engineering, we did learn a little bit of electronics, how an electronic systems works, like the timing, all that. So from that basic, you should be able to build up. Math, as an engineer, you have to know math. Right from school, you're learning math. So everything aggregates, linear algebra, simple differential equations, ordinary differential equation, numerical methods, calculus, simple transforms, filtering, how a filter works, analytical geometry, physics, there's all can be grouped into math, and that you learn. Okay. Systems engineering, this I did not learn in college, but I learned as I was working. Testing, anything you do in the lab is testing. You have a course, you go to the lab, let's say an electrical lab, and you measure something or you observe something, you are testing. So you do have that skill. Testing is basically you have an input, you observe an output, and you have a system, and you have some understanding of the system, right? And you from the outputs you observed, you make something out of the output. So testing. People skills. When you go to the job, you have to talk to your peers, your managers, your other teams that might be sitting in some other country. You have to probably deal with your customers. So these skills you have to start from your college. Working with people, that's very, very important in industry. Even though you might be technically very good, you have to be a good you should have some people skill. You don't have to be like the biggest orator, or wow, he's such a nice guy. No, you have to be able to communicate very clearly. You should be very polite, give respect, take respect, all that simple people to people interaction. When somebody asks a question, follow through that question. They emailed you something in the morning, you have in the back of your mind, before forgetting, you have to follow through that. Yep, hey, here's the answer to your question. You might be busy with a lot of things, and that's a people skill. Okay, so these are all the different skills I use. Like I said, except for a few things like the systems engineering and programming, the basic skills I had when I was an engineer. Okay, I learned from college. Okay, so how to build your skill set. You might be second year, third year, or fourth year of engineering. So like I said, my turning point or my area of interest came in my seventh semester of engineering, systems and dynamics. So till that time, I was just learning it, everything that was offered, and and not sure where I will end up. Okay, so but trust me, you will have your area of interest at one point of time. You say, hey, yeah, I like that subject. There's one subject you would like probably than all the other subjects, right? Choose that as your area of interest. And in that, how do you build your skill set? So a very, this I thought is an easy example. So you could think of a very lot more examples. So let's say for some student in mechanical engineering, it doesn't have to be final year, second year, third year, or fourth year. If you're interested in robotics, what skills do you need? You want to build a robot, right? A simple robot, all it has to do is that if you push a button, it just drive. Okay, think about it. To do that simple project, you need to think through a lot of engineering to make that robot on your press button. Even as simple as putting a wire, a switch, and an electric motor on something that has wheels. Okay, you need mechanics of machines. You need to put wheels, okay, and they need to spin, and they have to be a rotary mechanism, right? And that you have to attach your motor to it, and you have to size the motor properly. If you have your vehicle 1 kilogram, you cannot put a 100 kilogram motor on your vehicle, right? So you have to size them accordingly. Mechanism, strength of materials, math, that's a default. Math is a default for all engineering. Electrical drives. So the robot has different arms. It can be electrical drives, it can be hydraulic drives, based on how big or how huge the robot is, right? So you need to understand the basic of how an electrical motor works, how it is controlled, right? Programming. You need to program the robot to do a certain activity. I mean, all you push the button and it just drives off, that's great for a high school project. But then if you're an final year engineering student, you're not going to show that robot as your final project, right? So you want that robot to do something, maybe on an obstacle avoidance, or stair climbing, or flipping over, or something like that, and you need to program for that. Okay, simple programming. Programming is not that hard for a mechanical engineer. Trust me, programming is not that hard. It's very simple logic with you just write down in lines. That's all programming is. Okay, instrumentation, data acquisition. You need to know how your robot is doing. Is all the sensors are communicating to each other, to your logic. CPU, you need to have a CPU. A lot of people I'm sure will know about, like, Arduino type of a CPU that you can easily buy right now. So you need to work with that CPU, and you have to integrate that into your robot. Communication. So a lot of things are there in the robot, they need to communicate. For example, image processing. So this is a obstacle avoidance robot, so it needs to know where it is going. Some rudimentary image processing. So I mean, just an example, right? So whichever project you choose, you need to, as a mechanical engineer, unless you are designing a purely complicated mechanical part, okay, then you are building your expertise in that. You're building in your expertise in probably, how to design that part, how to stress test that part. You're building your expertise there. So if that was your area of interest, put that in the center. Say that machine design, CAD CAM, that's your area of interest, and try to list your skill set around here. So and see how many you have and how many you're missing. So how do you know how many you're missing? Okay, so you said you're the robotics is clear. I laid out the circle here. You write down your area of interest. Like I said, math is a given. The other, what are all you need? Okay, so for that you need to think about what is going to be your final year project and how are you going to build up to that final year project. Why I'm saying that is that final year project, choose that as a platform to basically that project can be just your resume, okay, nothing else. I once was trying to apply to SpaceX, the sister company of Tesla. I did not apply. Why? What they asked was, just shoot a video of your project from beginning to end. That's all they needed, and I did not have a project to send them at that time, so I did not apply. So that's all. That was their application. They did not want a 5-page resume, 10-page project report, nothing. They just said, send me a video of your project and talk through it. A 5-minute video. I don't remember, 5-minute or 10-minute video. That's all they asked for. A company like SpaceX is asking like that. So imagine what other companies will ask. So use your project as a platform to post your skills. And I think I talked over this slide already. So how do you build a skill set? Choose your area, find out your application, find out your system. So like I said, if CAD CAM is interesting to you, think in a lot of different direction. Who would use CAD CAM? Who would do machine designing? Who would what is the latest guy who would be interested in an expert of CAD CAM? How about a 3D printing machine company? They might want a CAD CAM expert, right? And 3D machine, without saying, goes with a lot of robotics, a lot of actuator, a lot of moving parts. Okay, so let me just leave there. So choose a system like that. Any system you choose, find what are all the application. System meaning your mechanical area of interest of mechanical engineering. And when you choose that area of interest, see what are all the application. Okay, fine, you found out an application. So what products use that application? What companies manufacture that product? Go to their job posting site and look for any job that if you are in engineering, don't look for a HR job. You can, I'm not just saying that, but look for an engineering posting and see what are all the skills they require. Okay, do that for 10 different companies. So this is my area of interest, and here are the 10 companies that they want these specific skills. Okay, get that in your mind. I need to build all these skill set to apply to any of these 10 companies, right? So based on that, choose your project well, and try to make your final year engineering project so that you can cover all that skills, and tell them when you go to the interview, hey, this is my project and these are all the skills, I think these are all the skills you listed in your interview, in your job posting. Okay. Don't think that companies always want somebody to give a one-page resume and then just tell about yourself. That time has moved on. That time has moved on. Now companies are more focused on how am I going to employ this guy in which job I'm going to put in. Most companies, they don't want to train you for 10 years or 5 years or even 1 year to do a job. They maximum want to train maybe for a few weeks to 1 month. Within that time, they want you to actually do the execution of the project, whichever they're hiring you for. So to do that, if they're hiring a guy who can train in 1 year, they're actually looking for a guy who has those skills and employed those skills in a project. Okay, so that's very, very important. So you cannot just say in a resume that, oh, I took all these 10 courses, so I have all those knowledge. Sorry, that's not how the industry works. You can have the knowledge, but have you employed that knowledge to something, right? So for project ideas, employ those skills. And then the last one, talk to your industrial contacts. When you go to conference, or even your uncle may be working in industry, just go talk to him, or uncle or aunt. I should be gender neutral here. I mean, uncle or aunt or anybody who is working, like, or your brother or sister is working. Hey, what does your company do? What is your product? What kind of skills do you use in your job? So go explore, and that's where we come to the last slide. Get out of your comfort zone, meaning that don't box yourself that, hey, I'm a mechanical engineer, I don't know what these electrical guys are doing. No, don't think like that. If I had not made if my friend had not asked me to take that systems engineering, the modern control systems in electrical department, I would not have a career that I have now. It will be completely different. I don't know what I would be doing. Maybe I'm probably working in an IT company for all we know. Okay, so go talk to other branch. I mean, they're also engineers. You always can give something and get something. They might learn something new from you. So given the time, let me shorten. I think this is the last slide. So you cannot master all areas. Choose 1 or 2 areas. Like I said, for robotics, we listed 7-8 areas. You cannot be a master in all those areas. That is not about like being master or mastery of all those areas. Get some skills in that area, or get some understanding of how you can work with all those things to build a robot. Okay, but still, when you design your machine or your robot, you still had your mechanical engineering skill, and you can be a master in that one area, and all other friends can help you. Your project mates can help you in other areas. Okay, and they can build up their expertise in those areas. Use your mentors well. When you're in college, don't underestimate your mentors. They might have gone through hundreds of projects. They would have mentored other students, previous year students, like so far. They would have so many ideas. So talk to your mentors. Manage your time. You have to manage your time. It's not easy when you have college work, homework. It's not easy to do an extra work towards your final year project to build a skill. Okay, it's not easy. That's why I've put like 5 stars to the 2 items. Time manage, hard work. There's nothing around it. So unless you are a genius, you can think of something. You have to do. Most of us, unfortunately, have to do hard work, and that's how you could get things done. Healthy competition. Talk to your peers. Don't always think that he's going to get more marks than me, or he's going to get a better grade than me. Who cares? I'm not the college first or state first, but that doesn't stop me from getting to where I am. Okay, so others can excel in something. You can excel in your own area of interest. Okay, the last thing, but it's not the least, communication and people skills. That's very important. So don't be shy to talk to your mentors, your professors, or your other friends in other departments. Okay. I think we have maybe I'll take one more minute. So project ideas. When you choose a project idea, keep things simple. When I said, a robot, keep simple what the robot can do. If you try to put too many things at the beginning that what you want the robot to do, finally you might not have enough time to finish everything together, and probably you won't even have time to even make the robot move. Okay, so that's just one example. Robotics is one example. Please take this idea as a general template, and then choose your project. So make a poster out of your work. So I don't take a resume and give it to my employer. So when I came here to this employer, I did not have a resume. I just had 4 slides of what are all my skills. Okay, 4 projects which highlighted all the skills he needed. That's my resume. Okay, make a poster out of your work, and that actually feels good when you put colorful posters of your work and you can talk through that to somebody. It actually feels very good. Okay, industry is looking for specific skills, not what all the mechanical engineering they're not looking for that. They're looking for specific skills. I put a question mark on IT profession because I did not go into IT profession, but I am sure if you have good skills and if you have that resume and give it to an IT company, I'm sure they'll take you. So believe me. And I did get my IT job when I was in Anna University, but I didn't join IT profession. But believe me, try to market yourself really well. Okay. We are towards the end of my slides here. So hopefully you got mainly the students who got or even to mentors who are mentoring the students have taken some idea from my talk how to encourage them, train them, or guide them towards their final year project, because that is their selling point to industry, right? Hopefully everybody took something out of this talk. And with that, I open for questions or any comments.
Yeah. Thank you, Mr. Ganesh. It was a wonderful session and very informative about the scopes and opportunities in the mechanical engineering and beyond. And first of all, we could able to see the automation machine of the CNH for the harvesting. It was a wonderful video.
There are a lot more videos than that. I think that was one video. I just want to show you what is the inside of the machine, but there are a lot of videos showing the actual harvest. That's actually fun. So
Okay, fine. So let's take up some questions. We have around another 5 minutes of time.
Sure.
So we will take up some questions. So one of the student, I like to work in the field rather than the system work. So called the design, etc. Though I am a mechanical engineer. So, can you suggest how to build my skill set or area of interest?
So you want to work in the field, right? So you are doing some kind of tech support, I assume. So you are in the field. First of all, whenever
I mentioned the field as maybe in the production or in the manufacturing line.
Okay, field meaning like outdoors or like in the plant.
Yeah, I think it's since he's a mechanical engineering, field means it should be a production line or manufacturing team, right?
Yeah, sure. So I mean, first of all, try to understand what is area of interest, and then choose a company and their product. So when you go to field, you have to have a lot of knowledge about the product, whichever company you're representing. The first thing you will be judged on when you go talk to in a field is what is the product knowledge that you have that the product that you're representing from your company, right? So that's the most important skill. Field, people skill. It's, I cannot trust that. If you say that you're going to be there at 9 o'clock punctuality, you be there at 9 o'clock. You tell him if you're late, please message him like, hey, I'm going to be late, there's a traffic here, I will get there in so and so time. So so try to put yourself in a position. I know that the student who is asking the question, he has some job in his mind, like a field job in mind. Think about how you would be in that position. Like, who would you meet? Who would you have to? Who's sending you from the company? Who are you meeting? And what is your goal will be to there? To what job are you accomplishing? You're paid for something, right? Doing some job. So think in that direction. That will give you some clarity on what skills you need to build.
Fine, sir. So one of my understanding is, what will be the scope of agricultural OEMs in India?
So I have not studied too much of the Indian market. I mean, New Holland. I mean, my case New Holland. New Holland is actually coming up with a lot of products in India too. They do not have combines, but they have a lot of tractors and other implements. There are, I mean, we have TAFE, right? I don't know if John Deere has facility there in India. New Holland has a facility in Pune, and they have a facility in Noida. There are a lot of agricultural OEMs in India, and they do mostly like tractors and crop preparation and like after harvest. There are plenty of opportunities there, because you will mostly they are looking for design automation right there, like automating a simple tiller or a seed planter. All of these have some form of not purely mechanical system. There are some form of electromechanical or mechatronic systems. So there is scope. You just have to go to their website and look at their products, what they're advertising. That should give you a clear idea. And if you want, I mean, I can try to do some search and send you a specific answer to that question.
Fine, sir. So that is one, you can say a tricky question. Sir, here in India, core companies recruit work experience from 3 to 5 years. Candidates, they are not interested in hiring freshers. So if they don't give us the chance to work, how can we become experienced?
So that's why you need to, if an industry is just saying that, looking at your application and saying that, 3 years you worked in this company, then you can work for in my company. Well, such an industry you cannot apply. I mean, I think that's really, I don't think there are purely industries like that. If there are, they probably need to change their hiring practices. But like I said, use your project to tell your employer that you did not just have the knowledge of a specific engineering, you have applied that knowledge, meaning you worked in that. I mean, you work. So industry experience is different. I mean, you cannot have an industry experience unless you work in industry, but you can come much closer. You can say that, hey, your job profile you posted is this. My project I have all the skill sets, and if you hire me today, I can start contributing tomorrow in your project work, in whatever project you're involved in, project work. Show the industry that you could do that. Give them that confidence. You have to show them. Show me your posters. Explain me what you did. How many sensors you, for example, let's say I'm hiring for my my team, and I will say that, oh, I can just take one question and then drill him there. I'll just say, well, let's say he has a robot and then there is some speed sensor. I can just take that one speed sensor and I can get out how much he has worked on that project and how much he knows about that speed sensor and how did he use it, how did he filter it, how did he integrate with the controller. And believe me, people in industry can know what you know and what you don't know. I mean, they can get out from by asking questions. So show me, if I asked you that, sensor or data acquisition experience needed in the job profile, show the industry that you worked on that such and such sensor. So that should give the industry an idea that, oh, okay, he's not just learned about it, he has actually worked on it, he has done something with it. So you have to do the work. I mean, and I'm sure if you show the work, they will be willing to make an exception for your experience.
Yes, sir. To add to your point, I can say that you should take up some kind of internship.
Sure. Yeah. I mean, that's part of curriculum, right? That's part of the curriculum, right?
Yeah, part of the curriculum means, the universities allows only, 7 to 8 days of internship for for a semester. But it should not be the case. You should take internship for minimum of 2 months to 3 months during your semester holidays, all those stuff, so that which will add value as you become experienced with a fresher tag.
Oh yeah, sorry, I automatically assumed that students nowadays go for internships. Like, I mean, it was a must for us. We have to get a signature from the industry that we went into an internship, and then we show that we did this project. We have to give a report, basically.
In India, it's still it's not leveraged like you should take more number of internship days. Still, our university, still emphasis on 7 to 8 days of internship permission during their academic days. But you need to add more number of days in the semester holidays.
So when you go for internship, here's what I would say: you cannot learn everything in 7 days, but you can learn at least what process they follow. Maybe in industry, you go to a manufacturing plant, you at least know what process they follow. They follow any quality control process, they follow any safety methods. Like try to get something from the your internship. So yeah, that is a good point. Like, I mean, you have to spend 7 to 8 days is not that long time, but you need to go for at least a month to get the feel of how the industry works. Okay, I think I'm in audio mode only. Hello?
Video is off, Mr. Ganesh.
Okay, yeah, that's okay. I think it says my connection is slow. I don't know if my connection is getting reset or suddenly it's slow. It would not let me click the video.
No, you can continue. Audio is clear.
Yep. Okay, I'll continue. Yeah, I mean, internship is what you added is a good point. So, other questions?
So let's take up the last question. So again, there are many questions in the related to internship.
Okay, I'm back. Sorry, I did not hear the last question. You were saying something?
No. So as you already said, right? So how to enable the students in the placements? So that is the next question. So as a freshers, so what are the basic skill they should be ready as a mechanical engineer?
Yeah, I mean, so you have to start thinking from 3rd and 4th year. I mean, second year would be ideal, but you have to start thinking about your industry right from second year. Third year you must be thinking. You cannot just come to fourth year and say that, well, I'll try to do something and then maybe get placed somewhere. That should not be the attitude. You should start thinking from third year. If not, you can take me as an example. For fourth year students, don't feel bad. Even in fourth year, you could do you can find your area of interest, and you can build up your skill set there. So if you're in fourth year, then you need to do a little bit extra hard work too. And fourth year, when I was studying, there's not many courses, right? You mostly focus on your projects. So there you go. You have all the time.
Yes, sir. So let's conclude the session, and it's time up already. We are 10 minutes delay. Thank you very much for the wonderful session, and I think the audience got a very good insight about what is mechanical engineering and what is beyond the mechanical engineering kind of career opportunities, and how could they use it for a higher education option, all the stuff. So thanks a lot, Mr. Ganesh, for spending your wonderful late night time.
Yeah, thanks for all the participants. Wish we had a better in-person session. So hopefully next time. Yeah, and thanks for everybody. And
yeah, we had almost 460 plus participants.
Yeah.
In the middle. And thanks to all the participants.
Yeah, thank you all the participants, and thank you, Bala, for coordinating this, and Sriram sir for asking me to do the talk.
Thank you all. Bye.
Yeah, bye.